Hey there, welcome back to the channel. So today we'll be working on finally the free function, which is on line 377. Okay, a miss. Yeah, so 344. So we'll be working on my free function finally. So yeah, let's get started. So my free function, first of all, what we will do. So we will get a pointer to a block that must be freed, but we don't necessarily want to add that block directly to the free list because you know there are other free blocks too that might be adjacent to it. So it would be better for us to merge those free blocks. So we have to check its left adjacent side and its right adjacent side to like know if they are free blocks. If both of them are free blocks, then that's a very big free block. Combining one, two, and three, like three blocks. If it's just the left free block, then it will just merge it. If it's the right free block, we'll merge it. If it's both adjacent blocks are allocated, we just directly add it to the free list. So that's what we are going to work on. So let's just get started. So we get a void pointer, so we get a pointer to our free blocks starting space. So that's what. So let's get the size of our block. So size t size t current block size. Sorry, dereferencing size t pointer, which we will cast pointer into. Not a single pointer, with char pointer minus size t size. So here we get the value of the current block size, and then we can uh, read the size of the current free block. And then if we want to check, so I'll write a function over here. Let's make it cool. So cool write free block. So it will take a pointer and it will just check if uh, the right free block is free or not. So let's do for the left one first because left one is easier. So what it will do, it will move pointer by two pointer sizes here. So size t size t left block size is equal to dereference constantly size t pointer char pointer minus size t size minus size t size. Perfect. And then left if left block size. So here, if left block size happens to be odd, that means it is allocated. So if it's allocated, sorry, my bad. So if left block size uh, and one, which means the size of the left block is one, which means it is allocated. So we can't do anything over here. So we just have to work on the negative statement of it. So this might be a better way, right? Or I can do like uh, what they say, like the this this operation. Uh, yeah, fine. For now, I will just do a negative negation. Yeah, if it's allocated, just give me the negative statement of it. Yeah, so this means left block is free. So it will just return true over here, and then return false. Yeah, for the right free block, it will also take a void pointer. We will get the size t for the right block size Size free pointer, char pointer. I'm sorry, guys. So pointer, and then we'll just a minute. Just give me a minute. Hello, hello, welcome back. So let's get into it. So we move our pointer by. So first of all, we need to get the size. Yeah. So size tree current block size is equal to size tree pointer char pointer pointer minus size. The same thing that we did over here. We should have just copied it. I'm so sorry. Size to current block size is equal to yeah, first. This is the same thing, right? Yeah, it's the same thing. Then we will move forward by current block size. So current block size plus size t size again, and then we'll reach this pointer, and then we double check. Yeah. So yes, this is fine. Yeah. We go over here, and then we move by current block size forward and size t size forward. Yeah, this is fine. So now we'll return if negation of right block size and one return true or else return false. So now whole left free is equal to left free block. We send in the void pointer. Oh, sorry. We just send in the pointer and then right, right. Okay. So uh, if left free, if left free and right free, so that means both the blocks are. Or should I just make it like a function? Um, and okay. So if left free and then right free, so your four conditions will be there. If left and right both are free, if just the left one is free, if just the right one is free, and the last condition, which is the else, like which is nothing is free, both are allocated. So okay, okay. So so left free, right free. That's fine. So left free, right free. This is okay. It will be a very big function, the free function, right? Uh, should we? Yeah, okay. It's not asking us for anything, so we can just. Yeah, okay. So let me just check one thing, which is this. Yeah, so many three pointer. Yeah, okay. Let's do it. Let's do it. Right. So we'll make the four different functions for this to make it like modular around. So left free. If both of them are free, so what we need to do is we need to add all the three blocks, and then we should add like we should move all of them to the like the combined version of all three of them to the starting of the free list, and whatever the uh, next pointer previous pointer handling is, that's what we have to handle in this. So let's just get started. So if left free, then we'll call a function. Let's say coalescing both, coalescing right left RL. Yeah, coalescing right RL. This is a means passing free pointer. We'll pass in R pointer. Well, this is fine, right? Coalescing RL, we pass in free pointer. Then we pass in R pointer. Okay, yeah, let's stop right here. So it's a void function. Yeah, I forgot we were supposed to do this. Why is void not highlighted? Yeah, okay. So void uh, coalescing URL. We take in a void pointer, we pointer, and the void pointer called pointer. So here we get first of all we do the same thing. We calculate the current size, and then so we get the current size, and then we are sure that we are going to merge it. So the uh, mhm. So we have to just do some like maths. We have to just change the size values and the previous and free pointers. Let's change the let's get the sizes for all of them first. So we have the current block size now to get the okay the left block size, which is this. So yeah, so left block size we have, and then to get the right block size, we need to do this. Yeah, okay. So now we have sizes for all of them. Um, then we are since what will be the addition of all of them? Let's say this is x. So let's say our current block is of size x. This is y and this is z. If we combine them, then the new free block will be of size x plus y plus z plus. Now we just get rid of 1, 2, 3, 4. So we'll get rid of four size t sizes and two pointer sizes. Size t size, four size t sizes and two pointer sizes, right? Okay, so we're just getting rid of this. We keep this x plus y plus z plus, let me just write this. Yes, size value, pointer, pointer. Yeah. Hmm. Total size is equal to current block size plus, well, let's call it left size. Just also, we don't need the current size, left size, and right size. Yeah, this is fine. Yeah, block size, left size plus right size plus this and yeah, audible. Okay. So by block size, left size, right size, and then we have four times the size, these sizes, and then we have twice just, and then we have uh, two pointer sizes. Yeah, okay. So the total new size will be this combined one. So that's what we have to change at two different positions at the start and the end of the new block. But we also now have to handle like the the what do you say, the pointers for all like the both of them. Let's make a function that will help us skip it about that. So let's make a function which is void skip block. What it will do, it will take pointer, um, let's say just call it pointer, and it will just skip it. Yeah, that's it. So it will take a pointer, it will skip it. How will it do that? Uh, skip skip block. So um, I should I should call this over here. So skip block. So let's get the pointer for both of them. So void pointer left block is equal to cast state tab pointer, the current pointer. This is taking in like the next pointer, right? The thing of us, the pointer, it will take in a pointer, we move it by size, the size. For any if you're not visible, this is what I'm looking at. So this is what it looks like. So let's say this is this is our middle block which needs to be freed, and so this is of X size. This is the left block which is of Y size, and this is the right block which is of Z size. So the combined size, we will just eliminate this 4S and these two T, right? We will just only keep this S, and these two pointers. So that's what X plus Y plus Z, X, Y, Z, plus 4 times sizes, which is these, and 2 times P. So that's what the total block will look like. like this. This is what it will look like. One, two, three, one, two, three, and the last one. So that's what we can easily change this as values, but this is what we have to mainly handle. These both of them. So yeah. So let's handle that. So left block size. So we get a size. So back again. So pointer minus. Well, now we have to move forward. So we are at this block. So we'll move forward by align size first. So right size plus two times of size, and yeah, that is it. Align right size plus size t size again. Yeah, yeah, we're basically there. So now we will like skip block for left block and for the right block. So now we have skipped the left and right block, and now we can change the values. So um, yeah, let's change the values. So we are at left block. So we have, our pointer already is already at left block. So let's just do it. So size t pointer left. Let's call it header. So size t header is equal to we are already over there, right? So cast is equal to size t pointer and char pointer left block, yeah, left block minus size t size behind, yeah, and then size t pointer footer. For footer, we have to do some gymnastics. So char pointer, we are already at the right block. So for right block, we have to move forward by two pointer sizes and right size itself. So right block plus two times of pointer sizes, yes, and the right size. Wait, what did we do over here? So for the right block, we just we didn't move the right size, we moved the current size, which is a block size. So here we move the right size, so two pointer sizes and right size, and then we're basically there. Two pointer size, right size, yeah, we're basically there. And then change the values of the header to total new size, We change the footer value to total size. Yep, good. And then here we will write the script logic. So what the script logic does is we get a pointer and then we get the yeah, let's do it first. So when we get this, let's get the previous in the next pointer. So void pointer, the pointer is already at next pointer, so let's just still do it. So next pointer is equal to pointer itself, dot, and previous pointer is constant void cat pointer plus pointer size is, and okay, okay, well we are at so we get a void pointers for this. Now we have to tell the previous block to change its address. So first we'll check if our previous pointer is like what we can say null. So if because if it's null, then we are in trouble. No, actually we are not. If the previous pointer is pointing to null, so yeah, if previous pointer or should I say like this we cast this into pointer. Yeah, we say that this is actually a pointer to pointer. So we say like if previous pointer if previous pointer happens to be null, that means we are at the if previous pointer is at null, that means we know if previous pointer so if we are here 27 minutes in, that's okay. So if previous pointer is equal to null, that means we are at the start of the free list. Then what we can do is we don't necessarily care, right? Yeah, let's still take care of that. So so if previous pointer is null, then we ask the then oh yeah, we should get here the address of the pointer to because we might have to change that to right. What pointer to pointer, pointer. Yeah. So here, if previous pointer is equal to none, then we just say like, sorry, so free pointer should now directly point to the uh, next pointer. But I don't get why we did this. Where is the logic that we are skipping it somewhere over here, right? Where did we ask for the block to skip? So we have over here inside the traverse function. No, not inside the traverse function. But if you give block this middle one, yeah. So it is. So if the next pointer to the previous block, the next pointer of the previous block is equal to null. If you find a privileged block at the very first position, Free pointer is equal to next point of the current block. Yeah, this is fine. Next point of the current block is, yeah, it's current. Yeah, yeah, yeah. Now, understood. Got it. Ah, horrible code. So, yeah, we have to get that. We do need to cast this into pointer to pointer. So the free pointer's position is to reference this and boom. So now free pointer points to next pointer and I should also change the previous the next block, right? Okay. Previous pointer is equal to I should also change like if the next pointer needs to be mm, okay. Let's so here we are checking if so skip block takes in a pointer and free pointer. We get the next pointer, the previous pointer. We check over here if the previous pointer is equal to none. So which means it is at the start of the previous. So we just move the free pointer to point to the next pointer itself. So that's cool. But if we have to also change the previous pointer of the next block, right? So if our first block is removed, then the previous pointer of the next block should point to none because like, let's say this is the first block in the list. This is the second block in the list. If we remove this, so now free pointer is directly pointing to this. This is what we covered. But if we remove this, this block's previous pointer should not point to this block, right? It should point to a free block. So that's what I'm concerned about. Let's do it. So when we are at the next pointer, so this is the next pointer. Yeah, let's get the next pointer. Next pointer. Oh, sorry, previous pointer of next block. Previous pointer of next next pointer of previous block is char pointer plus not this. How to get to the next block? It's tell the what did we do over here? So previous point of the next block. Mm, we cast that. Yeah, the next pointer. This is fine. Yeah, okay. Next point of the current block. Yeah, got it. Got it. Got it. Let's move to three. Sorry, 344. Sorry. So yeah. So let's say for the pointer. So next block is this dereference next pointer. And then we say previous pointer of the next block. So previous pointer of next block is equal to casting that boom boom cap pointer next block or I should have just next block. So next block plus pointer size, right? Now I'm at so boy pointer. We have the next we are at next pointer, and then we move that pointer size ahead. So we are at the pointer layer. So now we have to change this. So let's make it so like let's make it like this. We will add later on. So like let's say if previous pointer is equal to null, right? That's cool. But we should also add a check like if so over here if next block is not equal to null, right? So if next block is not equal to null, then we will go ahead and calculate uh, the you could say the previous pointer of the next block, and then it will dereference that. So previous pointer of the next block should be um, null. But if the next block is itself null, then we can't do anything about it. So free pointer points to next pointer now, and we check this. Okay, that's cool. But it happens to be like this, where our previous pointer is. Yeah, no confusion again. Okay. So here we write. So now we know the previous pointer is not null. So if previous pointer is not null, so you can't just move that free pointer now. You have to also take into consideration like the previous pointer. Shouldn't we say like the dereference value? Yeah, yeah. So previous pointer. So let's say the previous block. So void previous block is equal to dereferenced previous pointer. So where the so now we are at where are we? We are at the previous pointer of the next block, right? Sorry, next pointer of the sorry. Shoot. So when we dereference the previous pointer, we get the we get at the previous pointer of the previous block. Yeah, previous pointer of the previous block. Yeah, yeah, perfect, perfect. This is confusing. So okay, wait. Let me think. So if you want to skip this block, we have to take into consideration. Let me draw it. None, and this points to none. So we have W link first. This is actually free pointer. Yeah, perfect. So I'm not showing you guys what I'm doing because I think I will just, if there's a mistake, I'll just keep explaining and I will not think about it. So I guess it's better, it's better for me to think in silence. But I'll show you like what I'm. So I'm just let me switch this. Yeah. So I'm drawing a doubly linked list. I've drawn a double linked list. So that's what I am thinking about. Let me just think for a couple of minutes. Okay. So over here. Okay. So if previous pointer happens to be null, then we just need pointer over here. Choose the next block value. So next block is also. So if previous pointer is null, so there is no previous block, then we just move the free pointer to the next pointer. Free pointer might also point to null, so that's cool. But if it's not, then the next block is wait, we have to make this next block. Let's just make it next block. If next block is not equal to null, then we have to also change the previous one to the next block. So that's cool. If previous pointer, if there is indeed, so I have to change two values in this case. I have to change the previous pointer of the next block, previous pointer of the next block, and I have to change the next pointer of the previous block. Yeah, okay. So with this jutsu, I'm at the I'm at previous pointer of the previous block. So this is I should write previous pointer of previous block, right? Yeah. And in order to get to the mm, what is it, next pointer of the previous block, I should just do this constant void pointer, char pointer, previous pointer, previous block, move behind by pointer sizes. So now I'm at next pointer of the previous block. So that's cool. And then I will cast that into void pointer to pointer. Yeah, because this is what I hope to change. And then I will change this to point to uh, I will change this to point to directly to the next block. So next pointer of previous block should directly point to next block. Yeah, okay, that's good. So next pointer of the previous block now points to next block directly. And I have to check again, which is if the next block, if it's repeating, then I should. Yeah, let's take it outside. Yeah, okay. So this is cool. I guess. I hope. Let me think about this again. So I am over here. So I get a pointer. I get a free pointer. I say get the next pointer values and free pointer previous pointer values. This is just fine. Next block is at next pointers. Like difference, verify. So if previous pointer is equal to null, then you directly say like make the previous pointer and make the free pointer point to the next block. We don't care what the next block is. Else if the previous pointer is null, is not equal to null. So there is a previous block. So now we'll change that block's values. So void pointer, previous block is equal to this, dereference, this, next pointer previous block, and at the end, if next block is not equal to null, then we change that values. Yeah, okay. I hope this is clear. So next block. Yeah, yes, this seems correct. Later on when I test this, I'll later found that. Yeah. Sorry. So yeah, so now skip block is working. Uh, I guess how many minutes in? Yeah, 47 minutes in. I guess we will end this over here. Uh, I hope we have done some good changes. So we added three new functions, four new functions. Yeah. What is this? Yeah. So get diff, it's just this. Get status, nothing much. So get color, we have get branch, W, yeah, get status, get color. Started working on free function, or should I say free function, free functionality, free coalescing RL, coalescing right and left blocks. Yeah, get push, it's gone. Cool. Rejected log, coalescing. Yeah. So, yeah, I guess this is it. So, thanks for watching this video. I'm on my journey and I'm an engineer for fun. Bye.